Hi, I am Claudio Cicconetti from the Institute of Informatics and Telematics of the National Research Council in Italy, and I am the technical manager of the project EDGELESS. Today, I will show you a small demonstration on how we can have fun with node failures with EDGELESS. EDGELESS is a system that allows a client to deploy workflows. A workflow is a composition of functions that interact with one another using a graph dependency, as it is shown in the example in the picture. In EDGELESS, the work is divided into clusters. Each cluster is managed by a component called the edges controller, or econ. Each cluster is composed of a number of orchestration domains, each managed by an edges orchestrator, or e-ORC. In this demonstration, we will focus on a single orchestration domain, which is what happens within the green circle. So a collection of nodes managed by an orchestrator. Let's start with the first experiment. In this experiment, we will run workflows consisting of a single function, and those functions can be allocated on any of the nodes in the deployment. And we have a small deployment consisting of 3 edgeless nodes. One edgeless node, the one on the bottom left, is hosted on an NVIDIA Jetson embedded device. The one on the right, bottom right, is hosted on a Raspberry Pi. And then the third one, on the top right, is hosted on an Intel server, which also hosts the edges orchestrator and the edges controller. For convenience, those 3 components, controller plus orchestrator plus node, which compose a minimal deployment for edgeless, are also bundled in a single executable called edgeless in a box, which is very convenient for testing purposes, as we are doing it now. The user will create workflows on the edges controller via a command line interface called edgeless CLI. So the workflow will be created on the controller, which will start in turn it on an edges orchestrator, which manages 3 nodes, and the edges orchestrator will in turn start a function on one of the available nodes. Which one exactly will depend on the orchestration policy. In this demonstration, we will use a simple orchestration policy called random, which simply dispatches the start function at random among the available nodes. So what happens is that when we will run the demonstration, we will create one workflow after another, and each one will be assigned to a random node among the 3 available. The association will not be exactly that it is shown in this animation. We don't know what will happen. We'll see. So let's see this happening in runtime. So the 4 components occupy 4 shells in my screen. On the top left, we have the edges in a box, which are the controller, orchestrator, and one node, which we can start with this command. On the bottom left, we have the command line interface to create the workflows, and on the other 2 windows, we have the Jetson and the Raspberry, which we start as nodes. The workflow that we will create is a workflow consisting of a single function, this one, which is called NOOP, because it does nothing. It's like the no operation instruction on some processors. But it is sufficient for our purposes, since we're all interested into seeing where it will be allocated and what happens afterward. Here, the first function was assigned to the top left node, and we can see the one log entry. To keep the log clean in this demonstration, I filtered all the log directives which are not relevant to the allocation of new function instances. If we repeat again, now we see that the Jetson got the function, and now the Intel server again, and now the Jetson, Intel again, Jetson. And eventually also the Raspberry gets one, that's just random, etc. So we see that the assignment of new functions within workflows is done in a more or less random manner on the 3 nodes available. Let's go back to the example. So what happens if one of the nodes, for instance the Jetson here, disconnects from the orchestration domain? This is something that can happen for a number of reasons, including hardware failure or maintenance or network issues. If this happens, then automatically the Azure orchestrator will redirect the instances which are not running anymore on any node on the remaining nodes available. Let's see if this is the case. So I kill the Jetson node, and we can see that almost immediately the 4 functions have been redirected, one to the Raspberry and the others to the Intel server. If we are unlucky enough and also the Raspberry node fails, then also its instances will be moved to the only remaining node. As a matter of fact, now I kill also the Raspberry. We will see 2 more lines in the log of the Intel server, which is exactly what happened. And this concludes the first experiment. In the second experiment, now we will instruct the orchestrator to only allocate functions on nodes matching specific characteristics. This is a feature of EDGELESS that is very useful to guide the allocation on devices which the user wants to be used. So in this case, we will use the labeling of nodes. So we will have, let's see it in the test bed. Now I'm showing the configuration of the Jetson and Raspberry nodes, and also the one on the Intel server. There is this, in addition to the remaining configuration, which is not of interest for this demonstration. We have here a label saying Jetson in the Jetson device, a label saying LPI on the Raspberry Pi node, and while the Intel server does not have any label attached to it. By using these labels, we can tell the orchestrator that we want our function to be allocated on a matching node. So we can modify the workflow definition, and we can, by adding one more annotation to the function, which is called label match all, meaning that all the following labels should be matched. Now we have only one in this case. And now the orchestrator is not free anymore to send the function to whichever node, but it must match the one with label Jetson, which in this case, there is only one node with these characteristics. Let's start again all the nodes. And let's see what we expect to happen. When the client will send the workflows to the controller and then to the orchestrator, all the function instances will be started on the only node that matches the label Jetson. Let's confirm this. we see that the Jetson now is selected, and if we repeat again and again and again and forever, we will see that all the function instances will be always allocated on the Jetson node, because it is the only one that matches the label Jetson. If there were two nodes, then the controller would load balance between the two. But in this case, we have only one. Now, what happens if this node fails? If that happens, then we are unlucky, because it is not possible to use any other nodes, but the controller and the orchestrator will, since they promised the client that those functions will remain in execution, they will keep them alive in the soft state of the orchestrator without running on any instance, waiting for a node with matching capabilities to come up again. So let's kill the Jetson node. Now you see that neither the Raspberry nor the Intel server are assigned any function instance. But if we, for instance, we ask the controller if there are any workflows, we see that the workflows are still there. They have not just disappeared. If when the Jetson node comes up again, then immediately the orchestrator will create again those instances on that node which has matching capabilities. Let's see if this is the case by running again the node which on the Jetson, and we can see that without creating any functions from the client, we have all the functions that existed before associated with this node. This concludes the second and last experiment of this demonstration. Thank you for your attention, and I encourage you to check out the code, which is available as open source under a MIT license on GitHub at this link. Goodbye.